Anyway, welcome everyone to our Monday meeting. And get started with a company update.
We sold a bunch of tiny boxes this week. Money came through for 2 of them. You should email. If you order a tiny box and you didn't send the money, you don't get a tiny box. Yeah, we sold 2 tiny boxes this week. We've regressed. Well, I guess we'll talk about that soon. But yeah, we have to get back in the good graces of our only customer.
Yes. Hey. We can move on to next line items.
So it seems like the new linearizer caused a bunch of regressions.
It's not just that. Rangify also caused a bunch of regression, but we will talk about that later. We can talk about the good thing about the new linearizer.
Yeah, so I even cleaned it up a little bit more. It's even cleaner now. It's a linearizer is just a topo sort that has some priorities. So it's an opinionated topo sort, which is nice. I also factored if and end if out of the graph. If and end if are over, they were always kind of confusing. So the only place they're inserted at the very end just for renderers so that we can do gated stores. So the dream is finally happening with the deletion of a whole bunch of UOPs, or at least some places, and I've tightened the spec up a whole lot. So the spec is now pretty, like, we have 3 specs. We have the tensor spec and the tensor graph. We have the kernel spec for what's inside each kernel before codegen, and then we have the program spec, which is what's inside the kernel after codegen. I also worked today on PyRender, so you'll see that in Viz. The rendered stuff looks a whole lot nicer. It's actually kind of readable. So.
Why is it called control flow?
It should be renamed to linearizer, I think.
Okay.
That's just what Thompson called it. But yeah, so now spec equals 2 checks, both that the UOPs match the full UOP spec and that all of the 3 points PyRender, exec PyRender returns the same UOP. So. Yeah, I'll get that in. I'll get that in CI. It's a little bit slow right now, but I'll just disable some tests there. Figure something out about that. For flash attention, I mean, what kind of got me started doing this was that the devectorizer, not the expander, doesn't work for flash attention. So yeah, I mean, I don't know
what does that mean.
The expander, if you have intermediate buffers, okay, so there's 2 ways you can have an intermediate buffer interact with like upcasts. In one way, the upcast terminates at the bufferize, and in the other way, the upcast flows through the bufferize. But when the upcast flows through the bufferize, you have to make the buffer bigger. And this is easy to do when it's a bufferize, but hard to do after you've lowered it to stores. So there's some you can do in one abstraction and some you can do in the other abstraction. But in reality, I think that like we have a problem right now where shape is in 2 places. So we have shape in like dot shape, and then we have shapes in the D types. And I think we should unify all of that to one. And then the expander will basically be free. I also am starting to like really understand semantically what each one of these UOPs means. So like index selects a region, and then load, what load does is moves that region from whatever memory system it's in to a different memory system. So maybe D types will start including an address space, we'll start including a shape, and then we can like work on this stuff better. We can work on like like all of these intermediate buffers will be better understood what they are. But like I'm starting to see how it comes together where all these graphs are basically the same thing. Like we have this lowering of the bufferize to a store and a buffer, and it's the same for define globals and define locals. And soon I'll rename define global and define local. Like we're getting to the point now where this can all kind of be unified. So yeah, that's kind of the blocker on flash attention, getting the devectorizer and the expander to work. I could hack it, but I shouldn't hack it. I think I just waste time doing that. So get the expander to work. Then once the expander works, I mean, it does kind of work, but there's some sets of opt-ops that it doesn't work for. So I just want to like rewrite it to not even think about these problems. Then it's easier to think about what the online max trick is.
Yes.
Basically, the D type has a shape, and the shape is one dimensional. And there's no reason for this. They should be the same shapes, and it should be arbitrarily dimensional. And we can just have like a flattener pass, which puts everything in one dimension if we want. We can also unify. We can also unify JEP and index. JEP and index are pretty much the same thing.
Oh, that would be nice. Yes.
Yeah. We can kind of get rid of JEP. It's just index. It's all index.
Okay. Sounds good.
Oh, I also made a, so now when you look at the kernels in the PyRender, it like draws out the kernels. So you can check out what I posted in general. You can see how it's like split into all the kernels, and that's the beautiful MNIST trainer in like UOP format. And you can actually evaluate that and then schedule that and run it. And it'll
Can I
train
print this for Python backend instead of whatever thing?
So I looked at that, and yeah, we could definitely do this something else with the Python backend. But the problem with the Python backend is it's not really this, because this is for single UOPS that does the top of sort. The Python backend needs a list of UOPS
Oh,
because it's after cogen.
yeah.
Yeah, so that's how I was originally doing it. But yeah, I mean, we should unify a bunch of these things. I think we can now with these spec checks, we should be able to delete the old UOP pretty printer. I think this one's a lot better. Yeah.
It's nice. Sounds good. One last thing. You say something about NAN anti-dupe?
Oh yeah, I fixed a bug today. So float. So nan is not equal to nan, and we know that. But I thought that nan is nan, but nan is not nan. If you generate the nans with float quote nan, float quote nan. So here I'll post let me post a funny picture because I think I can do it with a dictionary. So if I make like yeah, check that out. Post a screenshot in general. See?
Yep.
So if you canonicalize that, if you do math.nan instead, it doesn't have that problem.
Oh, where was this causing issues?
Well, I don't really know. It changed the process replay a bit. All the nans just basically weren't deduping.
Yeah.
So
think
It's fixed.
generally, I think for NAND it's generally better to just use the mass dot version one anyway. So we probably want to do that. Like,
Yeah, we should always use the math dot version. Yeah.
Okay. Great. Let's move on to the next one. Next is OpenPilot regression. So I think there are two major big regressions for the vision model. One is immediately after Rangify. I think there's like a 10% regress, which is pretty much just the last big kernel. We have a very big kernel at the end that has a bunch of stuff. So that was slow. That one we can just hack by adding contiguous to cat or do something with that very big kernel that fuse at the end. Then there's the other one that's after the new linearizer. That's much. So that has a mixed effect. It made vision model, I think, 6 milliseconds slower, but make other policy model like 2 milliseconds faster. So I think that one is mostly just from the effect of removing the reorder, block reorder or block reorder, which I think is just because the load, the order is different and something like out of the for loop or something like that. That would take more look today. See how
it does do something concretely pretty stupid, and I remember this bug in the old linearizer, and it's hard to, we can think about how we want to beat it, but like the biases. So the biases are loaded before the ranges and then added after the ranges. So you're just wasting registers basically.
Yeah, I think it's something like that. Yeah, because
Yeah, we can think.
previously I tried to remove block reorder, and that caused some other issue. Some Onyx model won't compile. I think for now it's fine, just because we remove that model from benchmark. I don't know if we currently run that model that they're wrong or not. So there's that. Yeah. So I will see. So the good thing is this time it's not image value hack. So all the image stuff looks fine. So something else.
Great.
Yeah. Yeah, because Kama really wants to upgrade anywhere so they can benefit from all the USB stuff.
Yeah.
So yeah, hopefully you get this. I'll see if we can fix this this week so they can prepare for their Kama stuff. Okay.
Cool.
Next is fuse opting. Oh, this is the same item as last week. I spent probably 30 minutes on it, and I don't know what to do with this one. So it's not unique, because I have a hack that fix unique. I didn't fix this one. It's something else.
I haven't had a chance to look at it.
Yeah. So I have the command to reproduce this one in I think dev channel. But it currently works for, so it only fails for one of the Onyx tests and works for everything we put. So I added that to the test, but it's still not default. As we discussed earlier, it probably shouldn't be default for every optimizer, just for the ones that it supports.
Yeah.
So this is for, I don't know if we have any plan to change a sign or anything like that. Always feels confusing to me.
I mean, yeah, there's problems with it, but I don't know. It's not causing an issue with, like, the main, there's two major things we need for the contract. One is like a fixed lower that supports the like flash attention optimizations, and the other is like a fast backend, like Tinykittens.
Yeah, I think this is less of the contract. For contract, it can be more like specific focus on the model of the contract.
Yeah, we can also, like, I mean, there's a lot of stuff we can do for the contract too. Like, we don't even have to figure out how to find the optimizations automatically. We can just have contiguous pass in an arg, which is just Python that'll do an ASC transform.
Yeah, it's just like the DSP contract.
Yeah. But we need like two things are super important: tiny kittens and like the high level lowering stuff.
Yes.
Like the stuff that's going to fix the memory usage.
Yes. Okay, the next one is for Viz.
You hear me now?
Yep.
Yes.
So for this, I'm working through getting the cache counters visualized in this. NVIDIA has something in their tooling, but AIM doesn't really have anything that we can look at. So I'm trying to get these graphs in this. Currently, I have a UI that works, and also I can pull the counters from the CUDA counters. So next step is just hooking those up. I'll post a picture of that in general. This is how this is the graph that we're talking about. It's basically concerned about how you're utilizing your cache, and it's gonna help with our memory stuff too.
You got a screenshot of
These are
our replica?
this is NVIDIA's thing. Our
Yeah.
replica, I can share that too. Yeah, our replica is very close, almost there. This is our replica. Yeah, pretty much just
Sweet.
copied them. Yeah, gonna behave like all these graphs.
Yeah, we gotta like light up those arrows if it's big, but
Yeah, that's the plan.
cool. Yeah, so I think this segues into Nimmelgen, your top priority this week is to get these counters exposed, to get this UI actually wired out.
Yeah. Yeah, actually, that was my question if we want this, because SQTT is merged. Yeah, okay. So
Oh, we
we're
definitely want the
this.
counters. So the reason we want the counters is SQTT can never be free. SQTT will always have to be behind a flag, but I think these counters can be free.
Mm,
True?
yeah, yeah, almost free. We need just
Yeah, great.
some overhead to copy these. I mean, I think we just need some pockets to copy these data after each kernel execution. But yeah, I think it's almost free.
Yeah, I'm okay with Viz taking like a 10 or 20% hit, but there's no way we could ever enable SQTT by Viz equals 1. But I think we should be able to enable these counters with Viz equals 1.
Yeah. Also for SQTT, currently, like the design of SQTT initially was that we flush the buffers from the device only once when we so destruction of Python. So maybe we can do this, manage this a bit better and flush buffers after each kernel. So maybe this will require less VRAM.
That would be cool, yeah.
Okay, so yeah, I can look into that as well. Yeah.
But yeah, let's start getting this stuff wired up. Let's start getting this stuff in the UI. Yeah, and then just an update on I requested that other privilege from Apple. I think we'll give them another week to give it to us, and if they don't, we'll have to use a shim app.
Yeah.
It's probably not the end of the world if we use a shim app. I wonder if we could just even like open the mock port in a shim app and then forward it to Python.
Probably yes.
But yeah, I mean, the basic thing is that we need an app signed with our certificate in order to use the IO service open.
Yeah.
But it does work. I did confirm that what they gave us actually does work. And did you check? Do you have signing access to it as well?
Yeah, I also tested this. Yeah, it works.
Great. I mean, it'll be great to have all this this profiling stuff working with USB and our MacBooks, and we can all debug it easy. And yeah. Oh, a fun project for someone else who's listening to this. If you want to get CUDA, the CUDA compiler running on Mac in like a Docker container, that'd be good. Like just so like if you see like we have like MVCC compiler now, if you get that working on Mac, it'd be cool. So we can use CUDA equals one for Mac, not CUDA equals one, but not have to use NAC.
Uh, Anything else for this?
So that's what I think.
Nexus driver.
Yeah, so yeah, so for the USB GPU, I think we're waiting for Apple. I did some refactors in the PCI stuff. I think that I don't know. I don't have the 50 series GPU, so maybe if you can test these. So actually, I think the reset problem on Mac was caused because the addresses changed, and we basically should have remapped after reset. So maybe it should be better now.
Cool. Yeah, I can test it tomorrow. I'll try with that 5060 or whatever. But also, what about NV being? I guess yeah. Okay, we're still waiting on the new thing for the 580, so we can test it.
Yeah, basically, yeah, and currently 580 is blocked on the new client to Pi, basically because we even cannot update our runtime because it will break. Because of, like, they changed some structs, and actually these structs are like go directly to the GSP. So if they update GSP, our runtime should be updated as well. So and just
Yeah.
to fix this once and like for good, it's just to generate these online, like for each version. Like so, yeah. I think the cleaner solution will be just to use the new after-gen stuff instead of ifs.
Great.
Cool. Anything else?
No, so yeah, this week I'll finish these cache counters and maybe some other counters as well. And yeah, so I think I'll continue. Also want to merge QCOM, I think at least for the 7 series of Adrena GPUs, and I'll figure out something for the 8 series.
Great.
Cool. Okay, next is the Tiny Kitten.
I didn't get as much progress on this as I wanted to last week. I merged the map mode thing. It's not really that fast.
Well, yeah,
I mean,
because
it's missing
that.
a bunch of the tricks too.
Oh yeah. That's the most naive map model I could write, basically.
Yeah. So I double
I think
buffered
if
it,
you.
and it still only gets like 60, 70-ish.
So there's also warp group that might help you.
Is that on the 4090s?
Yeah, so warp group is not it's not anything special about the 4090s. Warp group just means that you use a 128. So you basically use the right now this is only using a local size of 32, which is only using one warp. But if you use warp group, that'll use basically four warps. The Thunder Kittens writes it pretty simply. So it'll use four warps, so it'll be able to overlap uh, loads and MMAs in the same CU. Like right now, even though it's double buffered, you're not being able to keep the tensor cores constantly fed because you only have one warp occupancy in the CU. But with warp group, you'll get four warps of occupancy, and I think I think that and double buffering alone should get you pretty good numbers.
Okay, yeah. I'll try that, and then I should also be able to get the flash attention example running.
Cool. But yeah, no, I mean, I think the thing to do here is to, yeah, first get their fast examples running, and then figure out how to implement these in Tinygrad.
Yeah.
Like in like the low level UOP stuff. Also, even with their stuff, we should be able to still get it working with our runtime. So we should be able to see all these counters and stuff. This is why we're getting all the counters working. It's time to really push on performance. But cool, I'm glad the map all got merged today. Yeah, check out Warp Group. I actually really like how they do it with like the warp : thing, which is like it's clear that that thing is running on the whole warp. And then Warp Group is like it's like the four. So I wonder if you literally just change that, if that would fix. That probably double the perf.
Now we also have the FP8 memo that you can test.
Is it faster?
Wait, how is it? How is this example double buffered?
Not the one that I merged. I haven't.
Oh, not.
haven't
Oh, you have another one. It didn't get faster. Okay,
yeah.
cool. But yeah, I think we can also get like really minimal stuff just to see, like, read the PTX and see, make sure we're doing the same layouts.
Cool. Anything else?
That's all.
Okay. Next one is for seats.
Hello. Yeah, so I got A-range folding and the big graph merged last week. It's nice. Found another A-range that wasn't folding. It should be actually pretty simple to get that one. Because you just have to, like, we only do A-range folding when there's a single range. And it's just, you just have to do it in 2 stages. And then I found the bug with cat splitting today, so I can get that merged for CPU now.
Cool.
And then we'll have to figure out how to render that for GPU DIMMs as well. And then
Yeah, once it's merged with CPU, we can go over that tomorrow.
Yeah. And I've also been trying to move the merge adjacent to the big graph, but I realized that the merge adjacent is like it's only merging like reshapes, but it's not merging permuted ranges. Because you have to try to merge the ranges also in permuted order. So I was just wondering how much I was just playing around, see how much there's to be gained by that. Because if you remember the example of like a transposed matrix and then summing the whole matrix, like that one still doesn't work. Um,
I see, but yeah, that's yeah. So you want to? I saw your thing about that. That's because that's on a reduce, right? You can try the reduces in any order.
Yeah, yeah. But well, yeah, the reduces. Yeah, you can permute. Yeah,
Well, the transpose matrix summing the whole thing would be a reduce, right?
yeah, um, yeah, yeah. The stores you can't do.
Yeah,
You can only do adjacent.
yeah. I mean, the stores like it's easier for me to think about this stuff while it's still in bufferize because like bufferize, we should think about how we want to express these things more generally. Like bufferize has multiple inputs, and these multiple inputs put the like if you have like two ranges that are both 10, the second one has implicit stride of 10, and the first one has stride
Yeah,
of like the rightmost has stride of 1, and the next one has stride of 10. So yeah, I mean we can think about if we want to like change that, but it's clear to me that's why you can merge adjacent ones. And yeah, not adjacent ones.
yeah. And I mean, I think also you want to try the split reduce op after merging all the reduce ranges. I think Chanyu posted something at some point about inconsistent split reduce op.
Yeah, we definitely want to first merge the ranges before we do that.
Yeah. Um,
I mean, the
yeah,
split
so I was just
reduce
trying
op
to.
is
Sorry.
the split reduce op is like a really basic thing. The code's kind of confusing to me, but the only time you want to do that, what that basically means is it's the same thing as group reduce, but on globals. So we can think about how like to
Yeah.
use the same logic. Um,
Um, yeah. Oh,
yeah.
and also I saw Chenyu's trying to get rid of the correct div mode folding. Um,
Yes.
one, I think it might be easier to change div and mod into floor div than to.
Oh, I don't think that's the issue though. So I thought the regression was causing by it's so the div mod is only correct if it's like numerator is positive or something like that. It has a limit. But the thing that regress
So the reason that it's basically like the way that the image, like when you do the image index, um, it takes an index and it does like a single div and a mod, and you can remove them if, right, if when your index is negative, you can fold the, or like if the you can get rid of the uh, valid if
Mhm.
the thing is negative, if the valid is true. But so we do truncating div when your index is -1, the div of that is 0. So your index is not actually out of bound. But when
Yeah,
you do a
but
floor div, like if your index is -1, then it's actually out of bound.
yeah, so my impression is the expression that was not folded correctly, it's because there's a outer 8 that was not considered when that expression is. So that expression itself cannot be simplified with the corrective mod, but if it's combined with the outer condition, that should be fine. That's my take for that flag and why we cannot take it
Yeah.
out, because our current rules it's only look at the index but not the outer valid.
Yeah.
So this
And
is
well, there's
this is
another
only
thing
correct
for.
given some conditions, right? And it's either, I think the solution is probably either combine the condition and the actual expression as a whole and they fold that using the correct rules. But it's also not a
Yeah.
important thing.
There's another thing you have to be careful with is it's like we rewrite mod as like mod by power of 2 as an and, but that's only correct if your numerator is positive.
Okay, I wasn't aware of
Yeah, we,
this, but
so it's like
I think the
there's
general
just like these 2 or 3 different things, and they're like interacting with each other, and like if you all leave them on, turn on, they will work. But if you turn one of them off, then you have to turn all of them off, and it's
So I
I don't know.
mean,
Yeah, it's hard to get it.
so there are certain things about I think we should separate like the correctness fix, like what's correct for every input, like versus like what's correct for image and other stuff in general. So we certainly don't have this concept of, I mean, we have the concept of a rewrite context, but we don't quite have the concept for given these constraints on these variables, simplify this expression. I think there's like u up given valid that's kind of like this. So you simplify u up given other u ups. But there are certain, it's not just image folding, there are other u up expression or kernels that can be simplified if we have a clear version of this concept. Because for now, if you have something like a valid inside a branch of another valid, it doesn't necessarily consider the outer gate. Although if you consider that, obviously you can simplify it further. So that's something I'm more
Yeah.
interested in. Okay. Anything else?
Not really.
Okay. Next we can move on to other bounties. B1TG got FP8 Tensor Core. I think that completes the original bounty. I already comment on the final PR itself. B1TG, do you have something else to add?
Hello.
Hi.
Oh, I started doing some experience on the MI 350 and the dev run script fails with MMU. And that it can train on single GPU with BS 128.
I think for these,
So-
it's more useful if you can find those smaller examples and say, okay, if running this script it fails, then people can take a look.
You mean I need to find the broken kernel?
Yeah, so let's start with finding which kernel with which optimization gives the MMU fault and is that consistent, or is this MMU fault something else? Maybe it's independent of the kernel because there are hidden states somewhere. I don't know. So for now, it's very hard for people to help you, other than running the whole thing and maybe wait until it votes.
Okay, I think I just working using a single GPU.
Yeah, usually if it's tied to a single kernel, then it should be able to find which kernel faults consistently. If you suspect it's due to multi-GPU, then reduce the GPU count so that you can still reproduce the issue, and just be aware of certain behaviors that's different between 2 GPUs and 4 GPU. Notably, the ring or reduce it would be different, so also test that. Other than that, if you still cannot like find a specific thing, let me know. I can help. I can take a look.
Okay.
Yeah, but usually just reduce the GPU count, reduce the batch size, try to find a specific kernel, see if it's consistent. Those things will help. Also, do you know why is FP8 Tensor Core not fast?
Tensor Core, no. I have implement all the shape the documents described
Okay.
or slower than half and bflow 16.
Okay. I just remember you said the FP8 Tensor Core example in your in simple memo is not fast. I was wondering why.
Yeah, I still have some.
I
still have
see the
something.
I see the double speed half ones in there now. Is that working?
What?
So I see there's the half tensor cores have been added that have the double size. Do those work, and are they twice as fast?
No, not fast. Not fast.
Not fast. Why not?
Yeah.
Okay. And another
Seems
general...
like a instruction with the FP8 scale. It may be needed to be faster with the FP8 scale support. I just run the instruction with scale 1. So maybe not use the instruction right.
Okay. I don't know. One last comment on FP8. I think generally for small D type, we try to match JAX. I think JAX has thought through a lot of these small D type cases. So we already discussed in one of the PR. And
Okay.
in general, when thinking about small D types and what rules we put, always think in a group for like FP8, FP16, bflow 16. All these like subflow D types should ideally have a similar rules. Use the least D type or least float. Use this to make sure anything you change applies to all small D types. I think that's much better than like one-off, because we are very likely to have other random small D type like MX, FP4 or FP40, whichever FP4. These things will be impossible to manage if we start to adding like one-off rules for one of those.
Okay.
Do we have like a group called small D types?
No.
You know what I mean? Like the way that we have like floats. We could make like small floats.
So for now we have like flow 16, bflow 16, and FP8S, I think.
Oh, FP8S. Yeah.
Yeah, so that's what we have for now. I think only if we start to worry about MX types, basically a type with a scale vector and a shape, we worry more. For now, we just treat it
Yeah.
as a single one. So okay. Next, I don't know if we have any update for Clan 2 Pi.
Yeah, I mean it's going well. It should be making pretty good progress on that. There's like one or two things that are left to fix, but it should work. Um, yeah, lib playing is kind of frustrating, but it works. Uh, yeah, I also haven't started the Objective C stuff at all, but I'm assuming that's just auto generate the stuff in ops metal.
Yeah, I think it should just work. I mean, Clang can definitely parse it. There was just stuff in the old one that couldn't deal with it. But yeah, the idea would be to generate the types for the ops metal and not have it
Yeah.
all be
Yeah. I think there's a
strings.
cursor type for the Objective C stuff, so that should not be a problem. Yeah, I also heard earlier that you were talking about running the autogen like every time the code runs, or I guess maybe like every time you install it, because there's some special thing for NV.
So
It's a little slow, so that's the only thing.
how slow?
Right now, I think it takes like 15 seconds to generate like all of the files, or I haven't set up all the
Oh, that's
files, but
fine.
it should take about
Yeah, it's not like we'd run it on everything. It would just be like cached. We'd have like a decorator.
Yeah. Well, NV is the
just
slowest
cache
one.
them.
Yeah. The problem is
Great.
parsing macros is really tricky. So the way I've been doing it is just like attempting to parse them and then execing the file, and then if it like fails, then you delete the macro that failed. So that's obviously like not very fast. And then also libclang is not very fast.
How do you get test data for it?
No, I just to see if there's syntax errors, because there's not libclang doesn't parse the macros very well or really at all. So it just gives you the token stream. So I just copy the C code into the Python file and then like run some transformations on it, and then if that's not valid syntax, then I delete the macro.
Is there an exploit?
What do you mean?
I mean, like, could someone write malicious C code that then gets executed?
Oh, I mean, probably. I don't know. I mean, we'll also like download a tarball and extract it for like the NP stuff. So if that got pointed to something bad, then like that would clobber your. That would not be good.
Fair point.
Yeah.
But cool. Yeah, good progress. I'll add another bounty also for if we don't have one for the Qualcomm. Oh yeah, we already have one. A Mesa backend for Qualcomm.
Yeah. Those were both blocked. I don't even know how the Mesa thing was working, because the structs are actually not the right size. I looked at that.
Huh. Yeah, I was playing with Mesa a little bit. I was using Samsung Dex on my phone, and I was playing with trying to get Mesa to build. I hope that compiler is better than the Qualcomm one. But cool. Okay, so I'll block on the Clang to Pi.
Yeah.
Sweet.
Hey. That's it. Do we have anything on the bounty? A bunch of items that has been there forever. Oh, I think the shrink and pad one is tricky for multi. Because multi you always do that.
I see. Okay, we can just delete that one. I don't know. Yeah, that one's not that great.
I mean, you can leave it. It's fine.
Deleted. There's some progress on the Winograd. I'll pay out half the linearizer bounty. I think T. Thompson and I split it. I think we did about. You gotta. There's definitely good stuff there, but to bring it all the way home was basically what I did with the ends and stuff. But
I double one for the pool removing pool implementation. I don't know.
yeah, 200 sounds good. Yeah, we could double that.
Yeah. Okay. So if people are interested in fix, I don't know what's left to fix the Torch tiny backend. Is they just fixing the as tried it, or if there's more? No idea. But
There's a
since we
bu-
are mentioned in TorchCom, probably a good idea to fix it. I don't know.
Yeah. There's a bunch of stuff.
Mhm. Bunch of how valid is those being equals to 3 test speed versus torch sub gem some thingy?
Some people were working on it. I don't know.
Is
I
it
mean, they're
just
just really hard. They're just really hard to do without like massively rethinking things.
or change the input size to be much bigger? Okay. There's
I'll delete
update.
the I'll delete the NV one. There's no way that one's gonna happen. The LVM ones maybe.
Update with the Whisper Web GPU. Seems to be some progress. Yeah, so generally for these ones, it's use your best judgment, and we will only evaluate the code and the output quality. So make decision yourself.
I just merged the spec equals 2 check tests.
Great. Mhm.
I think the other thing I kind of want to talk about is, do you think, okay, should shape and device be in the D type?
Say that again.
So I was thinking more about like what D type really means. And like, let's start with like, is device part of the D type?
Why should device part of the type?
Because like, if you have two buffers and you
Mhm.
want to do a mull on them,
Yes.
right? Like the D types need to match. But why have the D type just be like float? Why not also include the shape and the device?
Sure. So this is not just D type, right? You are basically creating a new metadata that you want to match this on.
Yeah, I mean it's not necessarily it's one piece of metadata, and like type is the right name for it, but it really is like the type of the UOP.
It's not clear, right? We don't have such a concept for tensor.
What do you mean we don't have a concept for tensor?
It's like when I have a tensor and I call tensor.dtype, do you expect it to also return you the shape of such tensor?
No, but I mean that's like a separate thing. It's like we have these three things that are like properties on tensor: the tensor, the shape, and the device. Yeah, I mean maybe okay. You're right. Maybe they don't actually have to be the same thing on the UOP. They could just be like different properties, just like that.
Yeah. So that I think that's fine, and because we have the same concept in tensor, if you want to create a new field and say that such field needs to match, that's fine. You can find a good name for that. But I don't think it should be like expanding the current D type.
You don't think it should be? Okay. I mean, the problem with doing it so you don't expand the current D type is that, like, the more of these things you add to UOP, the slower it's going to get.
Yeah, but then that comes with the drawback to make D type very convoluted, right? D type start with very simple idea and very simple promote lattice, and now it has a lot more to that.
Yeah. Okay. I see what you're saying. So you just want to add new parameters to the class.
Yeah, because I understand that there are many places that we check all three things: the shape, the D type, and the device are the same before we do stuff. And
Yeah.
if you think that always writing out that three is bad, we can have another thing that just combine the three. That's fine. But I don't want it to really cram into D type and kind of make it different from the one in tensor.
Okay. Yeah, I mean, it's just like we can start to do some really nice things with like reduce access could just modify the shape and not have like some like parameter thing for the axis, right? Reshape and expand are just the shape.
Maybe. I mean, maybe it can be something that expands the D type, like the PTR D type or something. I don't know.
I mean, I want to delete the idea of the vec on the D type.
Yeah, so that would be really nice because always you need to concern about the base of that D type.
Yeah. I mean, maybe I can just delete the vec and just like reuse shape for that.
Yeah.
Just reuse the existing stuff we have for shape, right? Because like the D type shouldn't. Yeah, it should be a shape.
No, that I'm really support. I was really support that. That's very nice.
I mean, but the problem then is like the reason I like it to be the actual D type is because like you have something like a load, right? How do you know if you're loading? Well, you have like an index. How do you know if you're indexing? I guess you should have shape. I don't know. I'll have to think about it. But okay, I see what you're saying.
Yeah, so I think because these concepts are it itself like similar to device, right? Device by itself can be very simple. D type by itself should be also simple.
Yeah.
Shape by itself should also be simple. So if there's a case that we can just separate them and keep them separated, that seems nice. It's similar to like the struggle we always have with image, because image has like one D type, one shape inside the shape, inside the D type, and other shape of the tensor. Stuff like that is hard to reason.
Yeah. I mean there's a different fix for that, but yeah.
Yeah. Cool.
Yeah. Okay. I'll try to see if I can use shape instead of using vec.
Yeah, that would be nice.
Yeah. The new vectorizer. Cool.
Okay. That's about time. That's about it for this meeting. Thanks everyone, and see you next week.